So in this video we're going to look at, I'll help you to look at how to create new CHP generation systems in your project if you'd like to look at them. So essentially, if you don't want to include a CHP system, simply we choose no on the drop down, and then we'll get our save and continue. However, if you would like to look at an existing, or a new CHP system or new CHP systems, we click yes, and again we click the save and continue. So we'll see beneath this, we're first of all going to be asked about new CHP system assumptions. So here we can add numerous different CHP systems. So we need to give each one a name. So I'm just going to call this new 150 kilowatt electrical. So we need to give the gross electrical power, in this case 150. The electrical efficiency, you can see that we filled it, pre-populated it with some assumptions, but if you look at your data sheets, you'll have the exact data here. So electrical efficiency, the thermal efficiency, the overall system efficiency losses is essentially any sort of electrical losses from generation through to where it's delivering. So typically we sort of put in 3% losses, i.e. 97% efficiency. We then need to choose the fuel type. So we've got three: natural gas, LNG or LPG. So I'm just going to stick with natural gas for the moment. And then we do need you to put in a CapEx for the system and the OpEx if there is any. So I am just going to put in £250,000 and an OpEx of £15,000 a year. Actually, this is a key point. O&M is actually on a per kilowatt hour basis. So this is per kilowatt hour of electrical that's generated. So you do need to sort of have an idea as to what kind of O&M you're expecting per kilowatt hour, which might be 1.5 pence or something. So remember, it's in pounds or in your US dollars or euros, etc., depending on the currency you're using. So I'm putting 1.5 pence per kilowatt hour of O&M. We can then add rows, so we can add multiple systems, but for this case I'm just going to add one. So once you've entered your system, you then need to click save and continue, and then we move into the strategy assumptions. And if you've looked at the video on existing CHP, this is the same. We need to tell the system when the CHP system is looking to run. So again, if it was working from the 1st of Jan to the 31st of March, we change that to March. If it was running between 7 in the morning and 10 at night, and it's only weekdays, and then we have a strategy. So follow net demand essentially means that whatever the demand is, the net demand after generation, reducing for generation and or storage discharge, essentially the CHP will output whatever the demand is, or max supply, which basically means it will produce if we look at the assumptions here, it's 150 kilowatt electrical. It will essentially generate 150 kilowatts electrical at max. Otherwise it can follow gross demand, which basically means that it will generate whatever demand before any generation is accounted for. Or we have a hybrid scenario, which will essentially look for the CHP system to fulfill charging of batteries before doing anything. We can also apply for this particular period that we've specified the percentage of the kilowatt hours that it generates that will be applied. So again, we can sort of say actually it's not going to be 150 kilowatts. It's actually going to be 60% of that. So we'll put the percentage in there, but typically that'll be 100. You can then add rows to make sure that you're covering all of the different periods throughout the year, and then you can essentially save and continue. So once we've done the strategy, i.e. how the CHP is performing, we just need to sort of talk about the savings assumptions. So this is essentially how much the system is saving in terms of thermal energy. So effectively, we've got two options. You can either, it's saving you on gas consumption, or it's saving you on steam consumption because of what's being produced. So essentially you can put the spread in percentage between these two here. If it's all gas, 100% there, and zero steam, or vice versa, or any mix. And then basically the savings for each of these per kilowatt hour thermal that are actually produced. So this is sort of thermal savings from the CHP system. We can save and continue. And then finally, we just need to know our fuel cost assumptions. So what are we using for natural gas, LNG or LPG? We've obviously stated that one of these, or the one that we're looking at, is natural gas, but obviously you could be looking at different systems with different fuel types. Then we need to know the different costs per kilowatt hour for those particular inputs into the system. So hopefully that makes sense. We'll save and continue, and then we move on to the next section.